Okay, so we're going to look at the components of a vector and putting it into vector form. This is concept 3B in your required homework. We have a velocity vector v that has a horizontal component of negative 34 meters per second and a vertical component of negative 72 meters per second. So let's just kind of sketch what that looks like. So if my horizontal component is negative 34, that's going to be in that direction, so towards the left. And my vertical component is negative 72. So if I were going to graph that, it's going to be in the downward direction. So what is the resultant vector for these two components? Well, we know that we can use trigonometry to get that resultant vector v. So the magnitude is equal to the square root of the x component plus the y component. And if we visualize that, imagine taking this vertical component and putting it here and adding them gives us that resultant vector. Now I have that right triangle situation, which gives rise to the Pythagorean theorem and what we're using here. So my velocity whole vector, this again is just in absolute value. So this just gives me the length. It doesn't tell me the direction. We have the square root of negative 34 squared plus negative 72 squared. And so our magnitude of our resultant vector is 78.8 meters per second. And if we're using proper significant figures, that's 79 meters per second. Now that's just the magnitude, so we also need the direction. Continue to use our trigonometry. There's actually a number of different ways you can do the angle. You can use sines and cosines, or you can use tangents. Typically, we traditionally use tangents because it's sort of kind of the method when we're given the adjacent and the opposite values. So we have minus, so this would be Vy over our horizontal component equals the angle. So it's our inverse tangent of negative 72 over negative 34. And the inverse tangent of negative 72 or negative 34 is 64.7 degrees, which was about 65 degrees. But we have to ask ourselves, does that make sense? So remember, tangent in our calculator is just going to give us values in the first and the fourth quadrant. So this is telling us the angle is in the first quadrant. When I look at my picture, there is no way that angle's in the first quadrant. It's in the fourth quadrant. If we quickly graphically determine the resultant angle, we know that it would be pointing down and to the left. So it can't be 65 degrees. So we have to add that 180, and we see that our true angle is equal to 245 degrees. So don't fall into that tangent trap where we just plug it into our calculator. Remember to think about what the physics represents and making sure we appreciate that trigonometry is only going to give us first and fourth quadrant, and we need to appreciate that we're not in that quadrant. All right, good job.